Okay, today I would like to introduce the antiderivatives involving exponentials and logarithmic expressions. We've already talked about derivatives, okay? So we'll warm up with a simple polynomial. The derivative, we follow the differentiation rules. So under this rule, this becomes 6, and you go down a power to 6x to the 5th, minus 105, x to the 4th would become 4x cubed. The derivative of a number times x is just going to be the number. And the derivative of a constant is 0. So the derivative is 6x to the 5th minus 420x cubed minus 204. Okay? Now, the integral follows the antiderivative rules. So the integral of f of x with respect to x is going to be the integral of x to the 6th. Actually, move this back. This is going to be the integral of x to the 6th minus 105x to the 4th minus 204x plus 177 dx. And we follow the antiderivative rules. So this goes up to x to the 7th over 7 minus 105. This goes up to x to the 5th. We put it over 5. New power on top is your new denominator. Minus 204. We go up from x to the 1st to x squared. Put it over 2. The antiderivative of the constant with respect to x would be the constant times x, so 177x. And then plus c to account for a constant. And then we will simplify this. This will be x to the 7th over 7 so x to the 7th over 7 minus 105 divided by 5 is 21, x to the 5th. Okay, 204 divided by 2 is 102, x squared, plus 177x and then plus the c for the arbitrary constant. Okay, so that was a basic polynomial, and now we're going to move on to exponentials. Now the derivative of 28 e to the x would be 28 times the derivative of the derivative of e to the x, which is just e to the x. Plus, this is not e, so we'll follow this rule. That will be 38 to the x power. And then you have your natural log of the base, 38. So that's your derivative. For the antiderivative, for the integral, we use the anti-differentiation rules. So this will be 28. The antiderivative of e to the x is e to the x. The antiderivative of 38 to the x, because 38 is not a, would be 38 to the x power over the natural log of 38, following that rule there. And then you have your cap plus c for the arbitrary constant. I'm going to pause here and put new examples on the board. All right, so over here I have a couple more. Example 3, we're following the derivative. For example 3, we're finding the derivative of x cubed plus 115 natural log of x. Well, according to the power rule, this is going to become 3x squared plus 115, and the derivative of the natural log is 1 over x. So f prime of x will equal 3x squared plus 115 over x. You get the 115 times 1 over x. That's it, I'm done. Okay? Now the antiderivatives, well, we're following the antiderivative rule, so this will be x to the 4th over 4 plus 115, And the antiderivative of the natural log of x is x natural log of x minus x. And then don't forget your plus c. This will be a distributive property situation. So we will have x to the fourth over 4. We move that down a little bit, make that a little bit more legible. X to the fourth over 4. So this will give me x to the fourth over 4 plus 115x natural log of x minus 115x and then plus the c. Okay? All right. Now for this one, I want the derivative. Now what we do for derivatives on this is I'm going to rewrite f of x as 57x to the negative first plus 89 natural log of x. That's a rewriting of f of x. Okay? F prime of x would be 57 times negative 1x. We go down a power for the derivative. So negative 2 will be the new power. Plus 89, and the derivative of the natural log is 1 over x. So f prime of x is negative 57, x to the negative second. 89 times 1 is 89 over the x. So that's the derivative. The antiderivative, well, I'm going to rewrite this as the integral of 57 times 1 over x. I'm going to factor 57 over x, or 57 over x into 57 times 1 over x. So again, I'm messing up. I need the integral. 57 times 1 over x plus 89 natural log of x dx. Okay, so I rewrote this. Okay? So, this will be 57. This will be 57. The antiderivative of 1 over x is the natural log of x plus 89 times x natural log of x minus x plus the c. Okay, and I'm going to need to re-engineer this for extra space. So this will be 57 natural log of x, the absolute value of x, plus 89 times x natural log of x minus x plus c, which gives me as the final answer 57 natural log of x, absolute natural log of the absolute value of x plus 89x natural log of x minus 89x plus c. Okay, and that will suffice for this problem. Put a couple more examples on the board. All right, I have a couple more, and then after these two, we'll have 3 more after that. Okay, the derivative of this. I would follow the normal differentiation rules. So this is going to be 99 times hx to the 7th following the derivative rules, plus 187, and the derivative of e to the x is itself, and the derivative of any other base to the x power would be that would be this same thing, 25 to the x times the natural log of your base. Okay, simplifying this, I would get 792x to the 7th plus 187 e to the x plus 25 to the x natural log of 25. Okay? Now in this case, we follow the antiderivative rules. So this is going to be 99 times x to the 9th over 9 plus 187 And the antiderivative of e to the x is e to the x. And for this is the anti-differentiation rule we use because that's not e. So that's going to be 25 to the x power over the natural log of 25. And then plus capital C to account for the constants. Simplified, this will be 11x to the 9th plus 187 e to the x plus 25 to the x power over the natural log of 25 and then plus C. Okay? All right. Next, we're going to do this one, and we're going to follow the differentiation rules, but we're going to use t instead. So first, f of t, I'm going to rewrite this as 65t to the 4th, to find the derivative, plus 152 t to the negative 1st. So f prime of t would be 65 times 4t cubed plus 152 times negative 1t to the negative 2nd as we go down power. Okay, so f prime of t would become 260 t cubed minus 152 t to the negative 2nd. Okay, now down here, we'll follow the antiderivative rules on this side. So this will be 65, and we're going up from t to the 4th to t to the 5th. And we're putting a new power on bottom as well as a denominator. Plus, I should probably rewrite this. Okay? So this is going to be the integral of 65t to the 4th plus 152 times 1 over t dt. Okay? Following this rule, this would give me 65t to the 5th over 5 plus 152, and the antiderivative of 1 over t with respect to t would be the natural log of the absolute value of t. And don't forget your plus c, which gives me 13t to the 5th plus 152 natural log of the absolute value of t plus c. Okay, I'm going to pause here and put up 3 new examples. All right, so these are the final 3 that I want to do right now. The derivative of 304 natural log of x would be 304, and the derivative of the natural log of x is 1 over x. So f prime of x is simply 304. 304 times 1 over x is 304 over x. Okay? Next up, b. The antiderivative of 304 natural log of x will be 304, and the antiderivative of the natural log is x natural log of x minus x, and then plus c, which will give me 304 x natural log of x minus 304x plus c. So we're done. Okay? Now, for this one, we're looking for the derivative. So this is the rule we'll follow down here. Okay? So that will give me 1 over x natural log of 33. That's it. I'm done. Okay? The antiderivative. This is based on the antiderivative, the integral. We will follow this rule here. So that would be x natural log of x minus x over the natural log of 33. And then plus c. Okay? Over here we're doing the common logarithm. If you don't see a base, you should assume it's 10. So the derivative rule will be 1 over x natural log of 10. Okay, and I'm done with that one. Now this one is the integral of log base 10 of x with respect to x. And this rule will be followed. So this would be x natural log of x minus x over the natural log of 10, and then plus C. And I am done.